Here we have a problem with conservation of angular momentum. So with conservation of momentum problems, you can always start by taking you got the cylinder, so we'll call that M1 is 25 kilograms, and R1 is 0.55 meters. So I1 for a cylinder, the formula for moment of inertia is 1/2 mr squared. So that's 3.78 kilogram meters squared. And then we have a 5 kilogram ball of sticky clay. So we'll call that M2. It's 5 kilograms. And it's dropped and lands 42 centimeters from the axis of rotation. So it's going to have a radius of motion of 0.42 meters. Now the moment of inertia for this guy is mr squared. Right? When you've got a point mass orbiting around an axis, then it's 1/2 mr squared, or it's just mr squared. Now it says it's a ball, which you might think, oh, that's a sphere, so it's 2/5 mr squared. Well, 2/5 mr squared is for a sphere rotating around its own axis, like a spinning ball. This ball is revolving around an axis. There's a difference between spinning and orbiting. Okay, so it's mr squared, which is 0.882. Alright, now that we got that out of the way, we're also told that the initial spin of the turntable, omega 1I, is 17 revolutions per minute, which we have to convert to radians per second, right? So we multiply by 2 pi radians per rev, and by 1 minute over 60 seconds to get 1.78 radians per second. So that's in MKS units. Now the clay is being dropped from above the turntable, so it has no angular speed to begin with. Alright, so let's see what we got. I1 omega 1I. Okay, so here's our conservation of momentum. Now we're lucky in this problem that we don't have to deal with the complication of I1 and I2 changing, right? I1 and I2 are the same both before and after the motion. Now, if this had been a problem where, for example, you've got a kid on a merry-go-round and the kid walks in or out, something like that, then the I would have to change and you would have to deal with that. But here, the moment of inertia is constant for the turntable and for the clay ball throughout the problem. In addition, we're told that the clay ball, after it lands on the turntable, moves with the same speed as the turntable, which means I can further simplify this in that